Now we're going to look at some other rules that we can use in conjunction with the power rule to make our lives simpler when we're taking derivatives. All right, so these are going to kind of be things you just have to copy down at first, but then we'll do some examples. So the first one is the constant rule, which says whenever I take the derivative of a constant, all right, so a constant just means a number. So this could be the derivative of 2, derivative of pi is just a constant number. All these are going to be 0. All right, so derivative of every constant function is just 0. All right, the sum and difference rule, we could do this with limits as well. Whenever you have a plus or minus of something you're trying to take the derivative of, you can break it up into 2 different pieces. So I can just kind of do these 2 derivatives separately from each other. Oh, this should have a minus sign on it too. I can do those 2 derivatives separately from each other and then just do them individually and put them back together at the end. You cannot do this with multiplication and division though. We'll have separate rules for that. And the constant multiple rule, this is similar to limits as well. If I have this number that's kind of hanging out, being multiplied by my entire function, I can just bring it out in front and just take the derivative of the function part without that constant multiple. So it kind of just hangs out at the front the whole time. All right, so now I can find f prime of this function. All right, the first thing is the sum or difference rules basically means I can take the derivative of each of these things individually. All right, the power rule says x cubed is going to turn into 3x squared. All right, then I subtract. I take the derivative of x squared. The power rule says that's going to be 2x to the first. And I'm going to add the derivative of 1. 1 is just a constant number, so I'm going to get 0. My final answer is just 3x squared minus 2x. All right, so you can see this is a lot simpler than using the limit definition, but we're using the power rule in association with the couple rules we just learned. Again, this one, separate them into 3 separate problems. All right, so f prime of x. For 2x to the fourth, right, we have the x part, x to the fourth, and this 2 is just hanging out. So we'll keep the 2 at the front. And then do the power rule of x to the fourth is 4x cubed. And then we'll subtract. This one is x squared with an extra 3 in the front, so the 3 will just hang out. And the derivative of x squared is 2x to the first. And lastly, 12 is just hanging out. X to the first is going to become 12, 1x to the 0. And then just simplifying, 2 times 4 is 8x cubed minus 6x. And x to the 0, anything raised to the 0 power is just 1. And it's saying all that's 1 now, so this is just plus 12. And so that is our derivative of that top function. And eventually you'll be able to say, you don't have to do this kind of middle step. You basically just end up multiplying those, derivative of x goes away. That's kind of where you're going to get to. Right now, writing out all the steps. And lastly, find the tangent line to this function at x equals 1. So if you remember the tangent line needs the slope. Well, the slope of the tangent line comes from the derivative. So the first thing we have to do is find the derivative. All right, and that's going to be derivative of x squared is 2x. We just saw the derivative of x kind of goes away, so we'll just have minus 4. And the derivative of the constant 6 is 0. So the derivative of that is 2x minus 4. I care about x equals 1, so now I'm going to plug in 1 into my derivative and get negative 2. So the slope of my tangent line is negative 2. All right, the other thing I need is a point, so I can put it into point slope form. The point comes from the original function, so I'm going to plug 1 into the original function. And that's going to give me 3. All right, so now I can go into point slope form. Y minus the y value I just found was 3. The slope was negative 2. X minus the x value I cared about was 1. And then just a little bit of simplifying gives me the slope of the tangent line for this function at that x value. So the slope comes from the derivative, and the points come from the original function. All right, but now I can find these values much quicker because I can use the power rule and these other rules to find the derivative function, plug in the x value I care about, and then I get the slope of the tangent line. All right, so it saves some time using these derivative rules over how we have been doing it before. So in class, we're going to practice taking derivatives with these new rules. We're also going to mix in some trig and exponentials and logarithms because those are other derivatives we know now. And then we'll be able to take the derivatives of a lot of functions, and we do some of these problems a lot quicker than we were when we had to use the limit definition every single time. So we'll work on that, practice that, and by the end, we'll be able to slay the day.